Okay, well, we're almost done. We just have 9-4 left to do with the odds. Those of you that have the 9-5 handout, hang on to it because we're going to be doing it another day. Okay, so 9-5 is just odds. And this is what we're talking about with symmetry. Now remember, we had a bunch of things where we talked about symmetry. Well, we had like the letter H. Does the letter H have line symmetry? Yeah, I can cut the letter H right down the center. And when I fold it on that, it's going to match, right? So that is one line symmetry. But I can also fold it here. Do you see if I folded it there, this side would match that? So that's a second line symmetry. That's what line symmetry means. But we can also have a thing called rotational symmetry. If I take my shape and I turn it 90 degrees, is it going to match? Here's the letter H turned 90 degrees. Is that going to match? No, it's not. So that letter H, hang on, I'm trying to make them, let me make them the same size. It's 3 long. Now, is that going to match that? No, don't look at this one. Now let's turn it 180 degrees. 3 long. And right in the middle. So is that going to match? Yes. So this is rotational symmetry. Does that make sense? We can have rotational symmetry, we can have line symmetry, and then sometimes we even have this point symmetry. And what that means is I can put a point like here on H, and if I spin it around, is it going to match again? Well, not so much on a letter H. It's tough to find point symmetry. It does happen, but it's the more rare occurrence. But in the letter H's case, I have both rotational and line symmetry, and that doesn't happen all the time. Let's go back to our card that we have here. Here's my card that's the number 2 of hearts. And do I have rotational symmetry? Well, we already decided we don't have line symmetry, because if I fold it anywhere, now some of you are freaking out that I'm folding a playing card, but this deck stinks. It's missing some stuff. So it's okay. Relax. So when I fold this, you can kind of see the creases. There's one crease. And if I fold that, this 2 is not going to have a match on that side. But if I fold it this way, the hearts match, but these 2s, once again, that 2 doesn't have a match on this side. This 2 has no match over here. So it doesn't have full line symmetry. However, if I took my playing card and I rotate it 90 degrees, it's not going to match because it's a rectangle. But 180 degrees, it looks exactly the same now. So this does have rotational symmetry, but it does not have line symmetry. So sometimes we're looking at things and deciding, does it have both, does it have one, and that's what we're talking about. So when I look at this picture, does this have line symmetry? If I folded it right there, would it match? No, that one doesn't work. If I folded it right here, would it match? Yes. So it does have line symmetry. But if I rotate the figure, and you kind of sometimes have to do that in your head, take it and spin it around, is it going to match up anywhere? No, it doesn't have any rotational. So looking down here at number 2, if I spin this way, is it going to match? Yeah. So it looks to me like this has both 90-degree rotation symmetry, and if I rotated another one, this is 180 degrees rotational symmetry. Now remember when we were talking today where we did counterclockwise and clockwise? This would be counterclockwise, and this would be counterclockwise. Although with 180 it doesn't matter, you can go either way. But we never go more than 180 degrees, because now we're going to go, we also have it at 90 degrees clockwise. We have rotational symmetry. And these are just like we were doing rules before when we did translations or sliding. We're going to have the same thing here. that we're going to give them direction as to what they do. So you need to do 3 and 5 and look and see, does this have line symmetry or rotational symmetry? So, and then if it does have rotational, tell me at what degree does it have it. Does it have it at 90? Does it have it at 180? Does it have it at 45? Just kind of think about that and give me some clarification there. This would be the center of that, and this would be the center here. So sometimes it's very important to figure out where is the center so you know what you're rotating around. Now this one, they want you to decide how many lines of symmetry does each polygon have. And you might have to give them a sketch. Well, an equilateral triangle is a triangle that has the same length on each side. Now, I might even break out a ruler if I was really doing this, because I would want to be thinking about that. But I would know that, look right here. If I put a line right there, that would match, right? But what about right here? Is that cutting it in half too? It is. And how about right here? Is that cutting it in half? It is. So how many points of, how many line symmetry do I have? Well, this is 1, and this is 2, and this is 3. I don't call this 4 because that's line 1. I don't call this 5 because that's part of line 2. So you're only going to count each line once. Now they want to know also, does it have rotational symmetry? If I rotated this point down to here, would it match? Yes. So if you had to calculate how many degrees that is, that becomes a little convoluted, but I would just say, think about how many degrees that would be on a protractor. And you aren't going to be given a protractor on your SOL, but I could, like here, I can line this up, and I can calculate, that's about, and remember this is going to be an obtuse angle, so that's about 120 degrees of rotational symmetry that would be clockwise. So 120 degrees clockwise rotational symmetry. Now you can go ahead and do 9. I should have done 8 for you, but I didn't. I'm crazy that way. So draw yourself a regular pentagon. Do the best you can on drawing the picture. Okay? On number 11, what is a conjecture? I'm hoping some of you will remember what that means. A conjecture is an educated guess. I want you to make a conjecture about comparing the relationship between the number of sides of a regular, that's a key word there. Remember what regular means. Regular polygon and the numbers of line symmetry. And to help you make that conjecture, you might actually do rough sketches of all of these, and that would help you kind of to think about that. So here, because I'm sure you don't want to draw a 40-sided figure, it's just wanting you to think about how many lines of symmetry is a regular figure going to have. Now, if I have a three-dimensional object and it has reflectional symmetry in a plane, rotational symmetry about a line, or both. Meaning, if I had a picture of a light bulb, a three-dimensional light bulb, and I put a plane somewhere in that light bulb, am I going to have symmetry? So let's talk about a pair of pants. If I have a pair of pants, can I put a plane somewhere in that pair of pants and I'm going to have symmetry? Yeah, if I cut it right down the middle, this side should match that side. So I would say, yeah, it does have reflectional symmetry. Does it have rotational symmetry? Is there any way I'm going to spin those pants around and it's going to match up? And I would say, no, it does have reflectional symmetry, but it doesn't have rotational symmetry. Because as it rotates around, I'm going to be looking at the side of the pants and the back of the pants, and nowhere is it going to line up perfectly. A round table, is it going to have reflectional symmetry? Yes. Now remember, we'd have another leg back here and another leg back here. But would it have rotational symmetry? If that's my line, when I rotate it around, do you see that this leg is eventually going to wind up right there? So it would have rotational symmetry. So in this one, it would have both reflectional symmetry and rotational symmetry. Think about a butterfly. I'm a terrible artist when it comes to butterflies. Is it going to have reflectional symmetry? Well, I don't know. I think the front's going to match. Yeah, I think it would have reflectional. Would it also have reflectional here? No, because it has the head on the top and there's no head on the bottom. So it only has one reflectional, but does it ever have rotational? Does the back of the butterfly look just like the front? Well, no, because there are legs on one side and there aren't on the other. So it's not going to have any rotational symmetry. So just a thought, something to think about there. So you're going to do 13, 15, 17, and 19, give me your best shot. You're going to draw something that you think has point, line, and rotational. I'm not so worried about point symmetry. Point symmetry is very much like if you spin it around like we were doing with the, like when we did these shapes. This is more of your point symmetry. Do we have a place where it can rotate it around? Oh, now a club uses a secret code word below. Describe the types of symmetry, if any, of each code word. Oh, it's even. Never mind, you don't have to do this one. So that's all you're going to be doing here on 9-4. Hope that clarified your homework there. And if you have any questions, please come and see me tomorrow during Spartan time. Thanks, guys.